They say game development is a precise science, a delicate balancing act of system, architecture, and international design. Anyway, so I decided to make a facility simulation game about managing highly volatile reality-bending aberrations. Why? Because my sleep schedule wasn't broken enough, and I looked at my C# compiler and thought, I can make this suffer. The core loop of the game is simple. You manage high facility tech, and you have researchers doing science, security guards holding weapons they absolutely should not be trusted with, and containment cells holding assets that want to violate the laws of physics. Everything is locked down, automated, and structurally perfect, except for the code I wrote it in, which is held together by digital duct tape and a prayer. This is one of our primary assets, the parallax. Its job is straightforward: look intimidating, pace around its cell, and wait for a testing protocol to begin. Naturally, the very first time I pressed play, it decided to do completely the opposite, and phase through solid steel and wander off into the endless void. Now, you'd think that a high-level aberration broke its containment perimeter, a massive facility-wide crisis would trigger. Alarms flashing, guards sprinting, total panic. But look at these researchers, they're completely chill, they're standing right next to it like they're waiting the line at a salad bar. Yeah, I should probably work on fixing. So, I paused the game to find out why my AI was refusing to acknowledge the literal mass casualty event, and I found the culprit. Look at this, a piece of absolutely ridiculous code right here. To trigger the red alert UI panel, the NPC script was using reflection to blindly hunt through every single script on the monster every milliseconds, searching for a private field that literally named lowercase profile, but the monster script declared it as a private field into Unity's optimization pipeline, and should have been a capital P in profile, but it's a lowercase, and that's how picky code is. And the anomaly just didn't escape its physical cell, it bypassed the space-time rules of object-oriented programming. It was escaping in complete dead silence. Now at this point, a normal developer would cry. But I chose to rewrite the hundreds of lines of codes that the system used to make a direct interface lockup. And boom, optimized clean, no more string passing of private variables. Now that most things are working, kind of, when an asset breaks containment, I wondered what would happen if we pushed the system to its absolute limits. Because why test a game safely when you can try to melt your graphics card? We have successfully spawned 500 facility staff members into a space designed for 6. They are currently vibrating at a frequency that shouldn't be legal in Unity. And let's give our aberration a speed and acceleration multiplier that completely violates speed relativity. Let's trigger the breach. Okay, so I think you guys have noticed the guards have a 0% survival rate against the supersonic anomaly, which is quite clear. I need to give them a defense utility, so instead of adding guns or some weapons, because I'm too lazy and we already have doors implemented, I just implemented a heavy containment blast door protocol. If an asset escapes, the guards can slam down the magnetic physical barriers to isolate the sector. So I've just spent about 3 hours writing the vector implementation for the door closing mechanism, and I calculated the mass, the downward velocity, in the custom physics collision matrix, so it wouldn't clip through the aberration. Let's see if that actually works. Right, so because I forgot to clamp the downward physical force on the collision matrix, closing the door doesn't actually contain the asset. It applies a localization kinetic strike that launches the aberration into low Earth orbit, or it just decides to no-clip through the door. So, space exploration protocol achieved! I'm leaving that feature in. With the scripts cleanly compiled, the interface linkages verified, the distance thresholds calibrated to a reasonable metric, and the space program blast doors fixed, it's time for a full-scale live simulation run. Let's see if our system can handle a containment breach properly. So, the facility didn't entirely implode. The UI canvas actually renders data when an asset breaks protocol, and we only corrupted a handful of meta files during the physical experiments. All things considered, an absolute win for data containment. If you want to see what happens when we introduce a completely new class of aberrations into the facility in the next log, make sure to subscribe button down. Data log closed. See ya!